Hi friends, let's fine-tune GPT-4o on a custom dataset with a custom data format. This feature is released just yesterday. Alright, we are going to do 4 things. First, prepare the training data, then validate the data, fine-tune the model, and finally use the model. Now, among these 4 steps, the most involved step is actually preparing the training data. Once we have the data, then validating, including the fine tuning, is super easy, as we are going to see. Alright, so today we are going to use a data set from Hugging Face. It's called Science Q&A. Alright, a lecturer deliver a lecture and then ask the student a bunch of questions. These are multiple choice questions. Now for each questions, there is a context or background information to it, and the student is supposed to answer either A, B, C or D depending on how many options it has. Okay, it's a very interesting data set. Alright, so let's load the data. It has around 20,000 records, and for the demo purpose, we need minimum 10 samples. Okay, so we are just choosing 10 samples to have to reduce the cost, training cost. All right, as I said, the most important thing is preparing the data in the right format. Now, since OpenAI models are chat models, they expect the data in this particular format rather than a Q&A, maybe a 2-column or 2-variable format. Okay, so what we need is, we have 3 roles. We have the system, how it's supposed to behave. We have the user input, and the assistant, which is the LLM, how it's supposed to behave. Okay, so we have 3 roles and each one has its own content. So here is an example. For the system, the content is Mark is a factual chatbot that also sarcastic. Okay, so that's like giving a persona to our LLM, right? And then the user content is what is the capital of France, and the model came up with this response, Paris, as if everyone don't know that already. Okay, this part is coming from the system prompt, right? We ask it to be sarcastic. Okay, so that's how we need to prepare our data. That's the thing involved. After that, it's super easy. All right, so here is our data set. It has lots of additional information in addition to what we see in this image. For example, it has an image, the grade, subject, so on and so forth. But we are only interested in what is the lecture, what is the question, and the corresponding answers or the options. Okay. So since the correct answer is in this format 0, 1, etc., we are going to, here we did a bit of data preparation to make it into this format, so that the LLM can either pick A, B, C or D, okay, instead of these integers. All right, so we did that formatting, and then we map it to the data frame. So as you can see now, the answer, it's in this format A, B, C, D, etc. Now, as I mentioned, we are only interested in 3 columns. So now let's prepare the user context. So currently we are working on preparing this user content, okay, for those 10 examples we have. All right, so the user content, it will have the context, which is the lecture content, and then we have the question, and then we have the options. Okay, so we are combining these 3 columns from the data frame, the question, the choices, and the lecture, these 3 into what is called this user content. Okay, so this is how it looks like. So the context, it has this context, and then the question, it has the question, and finally these options. Okay, all right, so we prepared the user content. Now let's write the system content or the system prompt. Okay, all right, so this is our default system prompt. The role, we are saying it's a science teacher assistant. The task, respond accurately to multiple choice science questions are provided by the teacher, and the instructions are for each question. You will be given 4 options labeled as A, B, C, D. Carefully evaluate the question and select the most appropriate option. And the output, it should only return the letter corresponding to the correct answer. Okay, so that's going to be our system prompt. Now, since we have the pandas data frame, here we wrote an helper function which we run through all the records to get our user content. Okay, so here we are iterating over all the rows and writing the output to this train JSON-L file. Okay, so this is how it looks like. So here is the first example. As we discussed before, we need 3 roles. So in the message, we have the system role and we have the system content. Okay, and this is the system content. So up to this point, we have the system content. So it's a science teacher, what it's supposed to do, so on and so forth, and it supposed to return only the answers either A, B, C, or D. Okay, so that's the system one. And then we have the user role. We have the user content, which also contain 3 parts: the lecture in the form of this context, and then the question and the options. Okay, and finally we have the role, which is this assistant, and here is the assistant content. Okay, so for 3 roles we have prepared the content. Okay, the system content is not going to change. For each example record, the user content and the corresponding assistant content will only change. Okay, so here is the last record, which is exactly the same. All right, so we have prepared the data in the form of this train JSON-L file. Okay, now let's validate the data. So OpenAI, they have provided some code, basically a bunch of helper functions to make sure that the training data in the right format the OpenAI models expect. Okay, all right, so let's load the data, and here we are just counting how many samples are there. All right, so there are 10 samples, looking good. And then here, this part of the code, it's super easy to understand. I'll share the code in the description below. If you have any questions, please do ask me. All we are doing is we are going over each example and making sure that the format as well as the content which it's supposed to have is there. Okay, so it simply said there are no errors found. All right. And then before training the model, we wanted to have some idea about the token distribution so that we can calculate the price or how much it going to cost us for fine tuning, right? All right. So again, these are the helper functions. All they are doing is they are taking the user content, the system prompt, and counting the tokens, so on and so forth. Okay. All right. And here we are actually invoking all those functions. The most important thing is checking if there are any examples which are missing the system message or the user message. So none of them are missing. That's good. And then if you are interested now for each question or for each example, what is the token distribution, the samples, so on and so forth. Okay, you don't have to worry too much about it. Now, in earlier versions of the models, we have a token limit, right? It used to be just a couple of thousand. So there we had to make sure that each example is within the input context length limit. But these models, they have 64 to 128 or even hundreds of thousands of token. We are going to train GPT-4o mini. So for this, we don't have to worry. None of the examples are above the token limit. All right. And finally, coming to the cost. So here, from the prompt, from the tokens and using the number of epochs, we are going to compute the total token. So the way the cost is going to be computed is how many tokens each example has, and then how many examples we have, and then that multiply that with the number of epochs. So we will have the total number of tokens and we have price per token. All right. Okay. So these are the total number of tokens in all our training data. And by assuming we are going to train the model for 10 epochs, the number of tokens we are going to be charged is this much. And here is the link to the pricing. For GPT-4o mini, it's $0.3 per million tokens. Okay, so this is a very small example. We are going to charge much less than $1. All right, so we prepare the data, we validate the data, and now let's fine tune the model. Fine tuning is the easiest step. OpenAI, they have created these high level APIs to make it super easy for anyone to fine tune these models. All right, get the client. I have my API key in my environmental variables, so I don't need to provide that explicitly. So first, we need to create the data set. Okay, that's using this client.files.create. Okay, so here is our file. When we do this, what will happen is the data gets uploaded to the OpenAI storage, and then we will have a file ID. So from the response, we will get the ID, that is our file ID. Now, when we are going to fine tune, we will be using this ID as training data. All right, let me show how it looks. So after running this command on my OpenAI console, this is how it looks like. So this is after training the model, but when you just create the data set, this is how it looks like. So train.jsonl. Okay, this is the file. Here is the file ID, which is what we got here. All right, so this is the file ID. And then to fine tune the model, we create this fine tuning job. Okay, we supply our training data in the form of this file ID, and then what model we want to fine tune, GPT-4o mini, and the number of epochs. Okay, so that will submit a fine tuning job, and we will get this fine tuned job ID. Using this job ID, we can track the progress of the training. In this case, it's hardly going to take a minute, but if you have lots of data, complex data, and you are training for a number of epochs, you can just invoke this function to check its status periodically. Okay, so list events, this will list all the events, and then using the job ID, as I said, we can get the status of the tuning job. And one of the output in addition to fine-tuned model is this results file. Okay, so here we have the results file ID. Now we can read the content of this file also using SDK, but I'll show you on the content on the console. So this is that file. Okay, so this is the file ID. Basically, it contains the training metrics. Okay, it contains the training metrics. You can download this file and examine. But if you go to fine tuning jobs, so this is the job we just fine tune, and somewhere, yeah, here we have the metrics. So we have for the 10 steps, here we have the training loss. I mean, this data set is so simple. We don't see this very high loss at the beginning, and as we train, the loss are reducing. We haven't explicitly provided a validation data set, but we can do that. Then in that case, the validation loss also computed separately. Okay. So this is our fine-tuned model. So it's fine-tuned. This is the original model, and then it appended this postfix. It's personal, and then a random string to uniquely identify our model. Okay. Some info or metadata about our model. This is our training data set. Okay, it linked to the file ID, so on and so forth. All right, so we fine tune the model, and then let's use the model. I mean, it's super simple. So again, using the response, we can get the model ID, which you can also get from the console. So let's run through a couple of examples. So here we have the lecture. Some chemical changes and it's related to physical changes, so on and so forth. And then here we are asking a question. So sewing an apron, is it a chemical change or a physical change? All right. So now we are invoking the model, this time with this fine-tuned model. All right. So we simply supply the system prompt and the user content, which contains the question, the options, as well as the lecture, right? So here our output is the content is big, exactly what we have asked for, right? We wanted only the label corresponding to the answer. That's looking good. And then here is another example. This time the output is A, which is also looking as expected. And finally, if you don't need the model, you can delete the model using the client. Before closing, just a couple of points. Now, don't go to fine-tuning or go to fine-tuning only if the prompting and related strategies doesn't work for you. Okay, because prompting is the easiest compared to fine-tuning, even though fine-tuning has a few advantages like higher quality results than prompting and ability to train on more examples. With the prompting, we have a limit on the tokens, right? I mean, even though these days we have hundreds of thousands of tokens, we don't want to provide all those examples at the time of inference as the context, right? That will do two things. One, increase the cost, also increases the latency. Okay, so only if you have such a complex scenarios where you needed too many examples, go for fine tuning. Otherwise, your first choice of preference always would be the prompting. Okay, and another advantage when we fine tune a model, again, since we are not going to use too many tokens at the time of inference, the latency will be much lower. But the disadvantages, its fine tuning is expensive. It requires hardware. Even if you are not buying, even if you are doing it remotely, it's expensive, right? And it also more LLM ops. I mean, if you are an enterprise organization, if you were to fine tune a model for each use case, that will blow up the LLM ops, right? As compared to simply prompting. That's all for this video. Thank you very much.